Hello and welcome to another session in mathematics. In this session we'll be looking at circles. Okay, but before that, let us take a review of our previous lesson. Welcome back. Our focus today will be on chord theorems, the theorems of chord. Okay, I defined chord for us in our last class. Last class we talked about chord, right? And who can remember what I said that chord is? Chord. Anybody? Okay, I told us that a chord is a straight line joining any 2 points on the circumference of the circle, and I illustrated that. I told us that this is what we call what? Chord. Okay, it can be something like this too. It's chord. As long as there are 2 points here that the straight line is joining, then we call it what? A chord. Okay, so let us look at the theorems of this chord, the theorems of chord. Let's start from theorem 1. In theorem 1 we have A, B and C, A, B and C. Okay, the A part of it says a straight line from the center of the circle to the midpoint of a chord is perpendicular to the chord. What do we mean? It means if we have a circle and then we have its center to be 0, we're talking of what? The center of the circle to the midpoint of the chord. Let's take here to be a chord. This is our chord. Okay, and then let's call it A and B, and then we'll draw a radius from here and join it here, draw another radius and join it here. It has formed what? A triangle. Is that correct? And then they said that a straight line from the center of the circle to the midpoint of a chord is perpendicular to the chord. That is, a straight line from here to this place is perpendicular to the chord. What does it mean? It means it bisects the chord into 2 equal parts. So this point is equal to this point. Okay, and remember, radius is always equal to each other. So the radius AO is equal to the radius BO. So the 2 radii are what? Equal. So in this, let's call here M. We say that OM bisects AB, which is this line here, line AB, into we have AM and BM. Do we understand now? So this line OM is a straight line which bisects the chord. Do you understand? Okay, that's why we said that a straight line from the center of the circle to the midpoint of a chord is perpendicular. Perpendicular means it bisects it into 2 equal parts. Assuming this AB was 24 cm, then when it bisects it, AM would then be 12, while MB will be what? 12. That is 24 divided by 2, since they are 2 equal parts. Okay, let's look at the B part of it. It said a straight line drawn from the center of the circle perpendicular to a chord bisects the chord. Is just what we just said here. It bisects it into what? AM and what? BM. Okay, these are the 2 points we then obtain when it bisects that. And then the C part of it says the perpendicular bisector of a chord of a circle passes through the center of the circle. Passes through the center of the circle. Let's just check if it is correct. Now this is the center of the circle. If you draw this down, it is the center. If you draw this up, it is also the center. It bisects the circle into 2 equal parts. So looking at the condition, he said the perpendicular bisector, which is the line OM, he said it does what? It passes through the center of the circle. So these conditions are satisfied. So let's go over to the second theorem. Theorem 2 says equal chords of a circle are equidistant from the center. What do we mean? We have our circle, right? And this is our center. Let's call it O, remember? And then we'll have a chord, first chord, we'll have a second chord, we have a second chord. Let's call this RS, and then take this to be PQ. Now I said equal chords of a circle are equidistant from the center. These are equal chords. PQ is equal to what? RS, because they are equal chords. Do we understand now? And it says that they are what? Equidistant from the center. Let's this is the center. Okay, so we bisect this into two. This is the center. They are equidistant. What does that mean? Okay, let's take here to be A and take here to be B. It is equidistant from the circle. That means that from O to A is equal to, let's call it OA, line OA is equal to from O to B, we call it line OB. Do we understand? That's what it means. It means that what? That these two chords are equal when it comes to the bisector here, the straight line that divides the circle into two. So from A to O is equal to from B to O. Do we understand? Let's form a triangle here and also form another triangle here. Okay, so looking at this angle here is equal to this angle here. Okay, this is angle 90, this is also angle 90. Do we understand now? So the B part of this theorem says that chords which are equidistant from the center of a circle are equal. Let us check that. I told us earlier that PQ is equal to RS. These two chords are equal. These two chords are equal. When we have any problem like this, and maybe they give you the value of PQ without giving you the value of RS, just bear it in mind that two chords are equal. Okay, then lastly says equal chords stand on equal arcs. Equal chord stands on what? Equal arcs. Is that true? What do we mean by arc? I told us that an arc is the point from here to here, and then the point from here to here. Okay, this is what we call what? Arc. So chords, equal chord stands on what? Equal arc. If B to Q is equal and R to S is equal, then these two chords are what? Equal. That's what the condition is trying to do, what? To make us understand. So looking at this now, we then go over to taking some illustrations giving the theorems. Let's take some examples. Example number 1, it says a chord of radius 9 cm is 5 cm from the center of the circle. Find the length of the chord correct to the nearest whole number. The nearest whole number. Okay, let us start. Okay, the first thing we must do is to draw a circle, and then we'll find the center of the circle. Told us that a chord of radius 9 cm is 5 cm long from what? The center of what? The circle. First of all, we draw our radius, draw another one, and then join it here. And we are told that the radius is how many cm? 9 cm. This is also 9 cm because the radii must be equal. Okay, so they told us that a chord of radius 9 cm is 5 cm from the center of the circle. So that means if we bisect this, then we have here to be what? 5 cm. 5 cm. Okay, now let's call here the point P and call here the point O. Okay, now looking at this, they said we should find what? The length of the chord. So we are looking for line. Let's call here AB. Line AB. We are looking for what? Line AB. Line AB from A to B. That's what we are looking for. Okay, if we bisect this triangle, then we'll have a right angle triangle where here is our 90 degrees, here is our 9 cm. Is that correct? And then here is our 5 cm. So let's title here X, or we call it line BB, since we are solving with half of this triangle BB. Okay, so looking at this triangle, let's go over to the next page. Here won't be enough for us. let me redraw it. We'll have 5 cm, we'll have 9 cm, and we'll have here to be what? PB. Okay, now looking at this, we apply what we call what? Pythagoras theorem. And I taught us this some time ago. Pythagoras theorem, which states that c squared is equal to b squared plus a squared, where c is our hypotenuse, this is opposite, and this is adjacent. So our hypotenuse in this diagram is 9, so we have 9 squared to be equal to b squared, which is 5 squared, plus line bb squared. Okay, making pb the subject of formula, we then have that line bb squared would then be equal to 9 squared minus 5 squared. Okay, line bp squared is equal to 9 squared is 81 minus 5 squared is 25. So we have a line bp squared to be equal to 81 minus 25 will give us 56. Okay, so to find the value of pb, we then take the square root of 56. Line pb is equal to 56. Square root of 56 will give us 7.483. 7.483. Now let's go back to the question. The line pb, that is from here to here, is what we got to be what? 7.483. But we are looking for the line AB. Now AB means this is half of this. We have 7.483 as our line BP. And remember, BP is equal to line AP. So that means we have 7.483 times 2 to give us the value of what? AB. And when we multiply that, we'll have our results to be 14.966. But they told us to equate it to what? The nearest whole number. And the nearest whole number here is what? 15 cm. So our line AB is equal to what? 15 cm. Okay, so that is settled. Let's take one more example. A chord of a circle is 24 cm long. Okay, if its distance from the center of the circle is 5 cm, calculate the radius of the circle. Okay, let us interpret the sentence. You say we'll draw a circle and we'll find the center of the circle. Then a chord of radius what? 24 cm. A chord of a circle is 24 cm. So this is our chord. This is 24 cm. And it says if its distance from the center of the radius is 5 cm, this is our radius from here to this point, and then from here to this point. And we are told that the perpendicular bisector is 5 cm. Then we are asked to find what? The radius. We are asked to find the radius. So let's call here O, A, B as usual. Then if we bisect this, let us call the bisector E. So taking half of this, we'll have a right angle triangle, angle 90. This is B, this is E, and this is O. And remember, here is 5 cm. So half of this now will be 24 divided by 2, which is 12. So here is 12 cm. Solving for line OB, line OB will then be equal to 12 squared plus 5 squared. Okay, then we'll have line OB squared to be equal to 144 plus 25. Line OB squared will be equal to 144 plus 25 will give us what? 169. And then line OB is equal to square root of 169, and that will give us what? Line OB to be equal to 13 cm. So the value of this is 13 cm. Okay, so thank you for being part of today's class, because we'll stop here. We've been able to cover the chord theorem of a circle. So to refresh your memory on what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. Do well to use the lesson note on the platform for better information on what we've just done, and feel free to leave your comments or questions on the comment section. Till we meet again in our next class, stay safe and bye.